guys, welcome to Paraclete TV. Kathleen here. Today we will be learning about proportional relationships. We will be able to decide whether two numbers are in a proportional relationship and be able to show this through tables, equations, and graphs. Okay, let's get into it. First, let's define what a proportional relationship is. A proportional relationship is a relationship between two variables and where their ratios are equivalent. Another way to think about this is one variable is a constant value times the other. Okay, so we have our definition here. Proportional relationship is one variable. One variable is always a constant value times the other. All right, so what does this mean? Say we have one variable x, and we want it proportional to y. What do we do to y or to x to make a proportional relationship? We have a constant value times the other variable. So if this is the variable that we have in mind, it's going to equal a constant value c times the variable y. Now we have a proportional relationship. Let's look at an example now where we have various values of x and we want to find the value y based on the proportional relationship that we define. So we have a table here, and we'll have x values and y values. Let's say we want a constant value proportion of c equal to 2. Now if we take arbitrary values of x, such as 2, 4, we'll say 15, and make one more box, 100. And we find the value of y that has a proportional relationship of 2 to these values of x. And we can. So if we have a set x, let's say for this first column x equals 2, we want to find y, so y equals question mark, and we know that c, the proportion that we want, is 2. So let's set up our equation. X equals c times y, which for this first column, 2 equals 2 times y. And like any algebra, we solve for y. So divide by 2 by both sides. Y equals 1. So we plug it in here. All right. Let's do the next column. So we have x equals 4, y equals question mark, and c equals 2. We're going to use the same equation over here. 4 equals 2y. And we're going to solve the same way. Divide by 2 by both sides. 4 over 2 equals y, but we know 4 over 2 equals 2, so y equals 2. Let's do the next one. If x equals 15, what does y equal? Well, 15 equals 2 times y. Divide by 2, divide by 2. 15 over 2 equals y. All right, and the last one. I think you guys can catch the pattern now. X equals 100, so 100 equals 2 times y. Divide by 2, divide by 2. 50 equals y. So now all these x and y values have a relationship, right? And the relationship is defined by this equation. X equals cy. But this c, we know, right? It's the constant value 2. So x equals 2y. So for every x we have, two y's will equal that one x, or we can rewrite it as if we solve for y, divide by 2, x over 2 equals y. So for every x we have, if we divide it by 2, that'll be our y. Okay? All right. It is important to remember that this equation, x equals c times y, can be used to define all proportions that we will have. X being one variable, y being the other, and c is the constant. Some tricks to make this a little easier. If you have two values of x and y, usually x will be the bigger value. Y is the smaller. And again, c is the constant. That doesn't always have to be the case, and you will be able to solve the equations regardless of whether x is bigger than y or y is bigger than x. But for simplicity, x is usually bigger than y. Okay, so now I have an example for you all. After I'm done reading this, pause the video and try to solve it by yourself. Okay, is 6 proportional to 18? If so, what is the constant value? And can we write an equation for all numbers with this proportional relationship? Okay, so pause the video now and try to solve it for yourself. Okay, so the answer is yes, 6 is proportional to 18. How do we know this? Well, let's look at our equation that we wrote before. All right, so we have x equals cy. Now, like I said before, it's easier to assign the larger value to x. So we'll say x equals 18, and thus y equals 6, right? Because we have our one variable and two variable, and we're trying to find the relationship between them. So if we plug x and y in for x and y here, 18 equals c times 6. And we want to solve for c. So divide each side by 6, divide each side by 6. C equals 3. So this is the proportionality constant that we have, 3. So here, the answer is 3. Now, can we write an equation for all numbers with this proportional relationship? And the answer is yes. Regardless of what x and y is, the proportional relationship is always going to be 3, right? Because c is the constant value. So our equation will be x equals 3y. You can also rewrite this, divide by 3 both sides, divide by 3 both sides. X divided by 3 equals y. These are the same equations, just written differently. So our equation here, x equals 3y, or x over 3 equals y. Okay, so now we have this proportional relationship, x equals 3y, or y equals x divided by 3. So can we find the same relationship for other values other than 18 and 6? And yes, we can. Here, I've set up a table for us with given x values, 3, 6, and 9. And we're going to solve for the y values. So, the first column, x equals 3. We can plug it into either this equation or this equation. This equation is easier because it's already solved for y. So, if x equals 3, 3 divided by 3 equals 1, and that equals y. So we'll put a 1 right here. All right. What if x equals 6? Well, 6 divided by 3 is 2. Therefore, y equals 2. And lastly, 9. X equals 9. So 9 divided by 3 equals 3. So y equals 3. Now, as you may know, when you have x and y variables, you can make coordinates out of them, right? So a coordinate has x, comma, y. So our three coordinates that we've created, 3, comma, 1, from the first column, right? Because we have our x goes here, our y goes here. 6, comma, 2 from the second column. And from the third column, 9, comma, 3. Now, we can graph these over here to make a line. 3, comma, 1, you go over 3 on the x-axis and up 1 on the y-axis. So that coordinate will be right there. 6, comma, 2, you go over 6 and up 1, 2. So that will be right here. And our third coordinate, 9, comma, 3, go over 9 on the x-axis because this position corresponds to the x, and up 3 on the y-axis, that's a 2 there. And so we can see that this creates a straight line through the origin, indicating a whole number proportion. We'll get more into this in the next video. But for what you need to know now is proportions can be defined by x equals c, y, where c is a whole number, constant value that will make x and y related. Thank you guys so much for watching, and I hope you learned a lot about proportional relationships, and I'll see you next time. Bye!